Matplotlib is a popular plotting library in Python. It's used for creating high-quality visualizations and graphs which helps in data analysis, exploration, and presentation. Key thing about Matplotlib is that it gives you complete control over every aspect of a figure or plot. Matplotlib was designed based on MATLAB's graphical plotting and to bring over those capabilities over to Python. Other advanced visualization libraries like Seaborn and even Panda's built-in visualizations are all built off of Matplotlib, and that's why it's important to learn some basics and get exposure to it. In this video, I am going to give a walkthrough on the use of Matplotlib in Python to plot some simple graph. So let's get started. So here, first up, we have to run this data. So what we did here was we imported numpy as np, and then we use the arange method to build an array for the variable x. If you check the arange method, it has a start, a stop which is exclusive, and a step which is 1 by default. See, it says here the default step size is 1. So what it did was, for x, it produced a one-dimensional array ranging from 0 to 99. For y, it multiplied each element of the x by 2, and for z, it squared each element in the list x. We will quickly check the all of the three lists here. See, x is an array between 0 and 99. Y, twice of each of element in x, and z is squared for each element in x. Now next we have to import matplotlib and set the inline method. So here we imported matplotlib using import matplotlib.pyplot as plt, and then we used a phrase %matplotlib inline. This phrase is used for showing the visualizations in the Jupyter notebook. This will only work in the Jupyter notebook. If you are using any other IDE, then this will not work. What we have to do in place of this is, after writing each piece of code snippet, you have to use a term plt.show at the end of the code. Like this. We don't need this in the Jupyter notebook, so I'm going to remove this for now, but this is the term you have to use in other IDEs. So now we will begin the exercise. We have to recreate this graph here using the following steps. So I will create the graph and then take you through it. So what I did here was, first I created a figure object using plt.figure. Now I am adding axis to this figure using add_axis method, and I will put in the coordinates for this axis. Well, it is given to be taken at 0, 0, 1, 1. Now what does this 0, 0, 1, 1 mean? This is the distance from the left, this is distance from the bottom, this is the width, and this is the height of this axis rectangle. So we are talking about this bottom left corner here. The first distance shows the distance. If you imagine the figure as a blank canvas, then this will be the distance from the left bottom left corner. Right now it is 0. It could be these numbers, all four of these numbers could be between 0 and 1. If it was zero point 0.5, then it would mean 50% from the left. Similarly, next term is 0 from the bottom. So this line, if it was zero point 0.5, would have been 50% from the 50% distance from the bottom of the canvas. Similarly, 1 and 1 means it is taking 100% area of the canvas. Now I am going to plot the x and y on this axis. So to plot, we just have to use the plot method with x and y. There are other parameters which we could add, namely we could change the color of this line graph. We could also change the width of the line, the style of the line. We will come to those terms later. For now, I am supposed to set the labels and titles to match the plot below. So this is our graph. As you can see in the original figure given here, this is much smaller in size. But on the x-axis we have the x level, on the y-axis we have the y level, and we have a title for title. On the graph which we have made, you can see x level on the x-axis, y level on the y-axis, and the title of the graph. And the line is blue in color, which was given in the original graph, so we don't have to change that. But this is the way to plot this. We will move to second question now, second graph. Here we have to create this graph using two axes, one larger axis and the other one is smaller axis within the larger axis. So once again, let me start plotting this. So I will start with figure object, which is plt.figure. Now, unlike the previous question where we plotted only one axis, now we have to plot two axes. So I will use the name ax1 and ax2 for those two axis objects. I will do this by adding axis to the figure object. So we have our axis. Now we have to plot this line x comma y on both of this axis. And then we have to give labels to this xy for both. We don't have a title here, so we don't need to worry about that. Now this will plot the xy line. It will also give the x level and the y level to the bigger axis. But what we see here is the line is in red or maroon color. So we can use the parameter color for that. This will be red in color. This looks maroon, so we could also give maroon here. I'm going to use the color red for the smaller graph and maroon for the larger one to show the difference between two colors. Also, for the regular colors, we could use the shorthand method of just the first alphabet of their name. Uh, so R for red. Similarly, we can use G for green, B for blue, Y for yellow. So you can see our graph here. This is the original graph. We had X and Y, X and Y. It's going from 0 to 100 on the x-axis and 0 to 200 on the y-axis. Similarly, here you can see on the graph we have plotted, it's the x-axis is going from 0 to 100, y-axis is going from 0 to 200. It's an x and y, x and y. And we use the red color for the smaller one, which is different from the original graph. But just wanted to show you the difference between these two colors. Color is R, which stands for red, and for the larger one we have used the maroon color. Now up next we have to recreate this graph. So just similar to the last graph, this one also has two axes, one smaller one inside the larger one, but here we are plotting different arrays, whereas in the last one it was same x and y array for both of axes. So here for the larger one we are plotting x versus z, and for the smaller one we are plotting x versus y. But see the dimensions here, it doesn't go from the x-axis doesn't go from 0 to 100, rather it goes from 20 to 22, and y goes from 30 to 50. If you want to check, in the last one we created, it was going from 0 to 100. So basically what this is zoomed in within x and y graph for just those values of x and y, and therefore they have given a title here, zoom, as well. We will use that as well. So let me start plotting using the same code. Now we have to plot x versus z on the ax1 axis and x versus y on the ax2 axis. We will also set the x level and y level for this and title for the smaller one. Now this will return our graph, but we still have to adjust the dimensions within the x and y axis. For that, we will use the xlim method and ylim method. Here, if you check the signature using Shift tab, we have a left value and a right value, and we also have x min and x max, but you only have to use one of left right or x min x max. If you use both, it will show an error. What this basically is, you have to use the dimensions for the minimum and the maximum value, and you could either pass in a tuple for this, or you can pass in a list, or we can directly put in the values here as well. So for the x, it will be 20 to 22. And for the y lim, it will be 30 to 50. And here you see our graph. This is much bigger than the original one, but as you can see, on the bigger axis we have x, we missed the z level here. So accidentally I had put ax2, I have corrected it to ax1 now. So on the bigger axis we have our x and z level, and that graph is exponential. On the smaller axis we have our x and y data. That graph is linear, but it has been zoomed for the x-axis to only show the dimensions from 20 to 22, and so therefore this looks much flatter on this zoom view. So here we have to create this plot. As you can see, unlike the previous one where one smaller axis was within the larger axis, we have two separate axes. To create this, we can use the subplots method. So here what we have to use is the tuple unpacking technique of figure comma axis. So unlike the previous method where we first plotted the figure and then plotted axis on that figure, subplots method is going to take care of both of those steps in the same step. Now as you can see here, we have two methods. One is subplot, the other one is subplots. The first one, subplot, also creates multiple axes within the canvas, but it is used for the functional method. It won't work with the tuple unpacking. The subplots method ending with s is a newer method, which is a convenience method of combining the two steps into one, where we could just uh, give the number of rows and columns, and will create that many axes onto that figure object. So the subplot will create as many axes as we want on the figure, and from there we could either iterate through the axis or index it one by one to plot on this axis. So here we need two axes next to each other, so it's in one row and we have two columns. So through this step we have created two blank axes here. What we did was we created a figure and then we plotted two axes on this. I will show you what this axis object actually looks like on the back end. So this is what we get through that step. We have two blank axes next to each other. Let's check the axis object. See, axis object is an array which has two elements within it. So what we are going to do next is we will use the indexation method to select each of these one by one and plot a graph on that. Now see the first one, this line has blue color and it is a dashed line. So we have two components here. One is the color of the line, the second is the style of the line. So we could do it in two ways. One is we could individually use those parameters like this. So for color we pass in blue, and for line style we have to pass in a dash. Those that would be two hyphens back to back. For the line style, rather than writing line style, we can also use the shorthand method of ls. Similarly, for line width, we could use lw as the shorthand method. Now this one is red in color and it is not a dashed line, it is a solid line. I will show you what we could do is we could copy this parameter here. We can copy this parameter and pass in the color red for the color and a dash for line style. We can do this, or rather than this, we can also use a shorthand method where we can directly pass the alphabet for the color and then the line style. This would work for the dash line and this will work for the solid line. So we get our graph. Now the lines look a little thicker in the original graph. So for the line width, we can use LW method and we can change this number to any number we want. Higher the number, thicker would be the line. So I think we will go back to 3. So what I did here was I used this LW method for line width and made it thicker, and I also use a method plt.tightLayout to separate these two graphs. In the original graph you can see these numbers were overlapping with the first graph. uh, Using the tight layout method it will separate out two graphs. So next up we have to resize that same plot to look like this. What we have here is this have higher height than the width. Here we have more width than height. We can do this by using the fixed size parameter inside the subplots. So now our graph looks similar to the original one. The only difference is this one is a solid line and this is dash line. We can change that as well. One dash for solid line, two dashes for dash line. Now it looks the same. Next we have to save the figure as PNG image. We can call this figure using the fig object. To save this we will use the save fig method. To check the signature of the savefig method, we need to provide a file name, and it could be saved either in PNG or JPEG or JPG or PDF, any other object. The image will download in the same folder in which we have this current Jupyter notebook. Now, if you want to explore more about Matplotlib, you can go to its official website, matplotlib.org. On the Matplotlib website, you will find all different types of plots which can be plotted using Matplotlib, user guide, tutorials, examples, and cheat sheets. Select the plot type, and then you can select any graph you like. Just click that, and you will see the details of the graph along with a code snippet regarding how to plot the graph. You can go through tutorials and examples to learn more about those. You can also go through cheat sheets. Here you will see cheat sheets for beginners, intermediate, and advanced users. You can download these and store these in a safe place, as these are handy way of quickly going through the plotting technique in Matplotlib. So in this video, we plotted two kinds of graph. First was for the individual plots on a canvas, where we built the figure object first. Then we added axis to it using add underscore axis method, and then plotted the XY values. Remember, multiple axes can be built on the same canvas. We could also pass in the parameter for changing the line colors, line width, and line style. Next, for plotting multiple plots simultaneously on the canvas, we use the subplots method using tuple unpacking technique. Here, we need to pass in the number of rows and columns, and Python would automatically adjust the size of the axis. Then we could either iterate through the axis using a for loop, or we could index the axis for plotting our graph. So that was all for this video. Thanks for watching.